Hi everyone, my name is Tim Roughgarden, and this is a video about mental models for blockchain protocols and Web3. This video is non-technical. For example, I'm not going to assume that you know how to program. I'm not going to assume that you have any background whatsoever in, say, computer science or in engineering. I'm really just going to assume that you are someone interested in learning more about what this technology you might have heard about, right? Blockchains or blockchain protocols, and Web3, you just want to know more about what it is. Like, why is it interesting? What functionality does it give us that we didn't already have with previous technologies? For example, I think most of us have a pretty good mental model at a very high level of the internet, right? That's some kind of like postal service in effect for digital data, right? It's some network that spans the globe that allows you to get zeros and ones from point A to point B. It lets us send email, it lets us browse the web, etc. And so the point of this video is to give you a sort of similarly high level but also similarly accurate model of blockchain protocols and Web3. I think this is sort of general education stuff. I mean, I would love it if kind of, roughly everybody knew this material, the same way we all more or less know what's going on at a very high level with the internet. Frankly, almost nobody knows this stuff. So if you get through this video and retain the information herein, you will actually know a lot more about this technology than almost everybody that you might meet. So on some level, the goals for this video are really quite modest. I just kind of want to convey two things. But again, they're both very, very important, and really very few people understand these two things. So first of all, again, I want to give you mental models for this technology, for blockchain protocols and Web3. What fundamentally is this technology trying to achieve? Why is that functionality interesting? And why don't we already have that functionality from other technologies? And just to sort of fast forward to the answer, what this technology is trying to give us is something which on the one hand has the general purpose functionality of a computer, right? Like, we all have, we have a laptop, there's lots of different applications we use on that laptop, Microsoft Word, Photoshop, etc. Obviously, computers can do lots of different things, and that's really cool. But at the same time, in addition to general purpose computing functionality, we want this computer to have the decentralization of the internet. We'll talk more about what I mean by decentralization later on, but again, we actually kind of have an intuitive understanding of the internet being decentralized, right? You never hear about someone calling up the CEO of the internet, right? We know that sort of no one person or corporation controls the internet. Rather, it's the product of cooperation by lots of different types of organizations all over the world. That's the sense in which the internet is decentralized. So again, blockchain protocols, they're trying to give us on the one hand the general purpose functionality of a computer, on the other hand the decentralization of the internet. So the one sentence version of how to think about a blockchain protocol is as a global shared virtual computer, or a little bit more precisely, the operating system of such a computer. And if all those words don't make sense, don't worry about it. All of the rest of this video is going to unpack those and make them very concrete. The second goal of this video is to give you clarity about the distinction between two different parts of the technology stack. Okay? One part is called the infrastructure layer or infra layer. The other part is called the application or app layer. And the application layer, that's kind of just like programs that we as end users would interact with. The infrastructure layer, that's all the sort of really difficult kind of engineering and computer science that enables the functionality taken advantage of by applications. So we'll get into it more in a little bit, but as a loose analogy, right, when you're using your laptop, you can think of the application layer as the stuff you're using, right, Microsoft Word and Photoshop, and you can think of in that context, the infra layer would correspond to sort of the hardware, like your actual physical computer, and arguably the operating system on top of that computer as well. Or another way of thinking about it is you can think of the infrastructure layer as everything that's sort of under the hood, right? So like in the context of the internet, that would be all the sort of hard engineering and sort of computer science that goes into actually getting a bunch of zeros and ones from one point A to another point B. And the application layer would be referring to productive uses of that technology. Again, in the example of the internet, that would be things like sending email, browsing the web, etc. Now, many people, when they hear the word blockchain, they immediately go to thinking about cryptocurrencies. Or in many cases, they immediately go to thinking about one cryptocurrency, like for example, Bitcoin. And if you remember only one thing from this video, I would be ecstatic if you remembered the fact that blockchain protocols and Web3 are a very general technology, much, much, much more general than just cryptocurrencies, right? It's like, email is a specific, very useful, very common, but very specific thing you can do over the internet. As we all know, there's a zillion other things you can do over the internet as well. For starters, you could, for example, use the web. And in the same way, cryptocurrencies you can almost think of as like the email of blockchain protocols, right? They're definitely an application of the technology. They're a very important application of the technology, but it is one narrow use case of what the technology is capable of. And then, of course, speaking about a specific cryptocurrency, speaking about like Bitcoin, well, that's like talking about one specific way you might send email over the internet. Like that's like talking about Microsoft Outlook or something like that. I don't mean to belittle Bitcoin. I mean, it's amazing. I mean, think about it. It's a new $1 trillion asset created out of thin air from software, right? We kind of take it for granted now, but if you stop and think about it, it's unbelievable. So no argument there, but just remember that's one very, very specific thing that blockchain protocols are capable of. So let's jump into the first goal, mental models for blockchain protocols and Web3. So again, one way to think about it is we want, on the one hand, the versatility of your laptop. Okay, the general purpose functionality of a computer that can run any program you can dream up. Okay, Microsoft Word, Photoshop, a zillion different examples. On the other hand, unlike a computer, which has a single owner, single operator, right? You just sort of push a button and you can turn off a computer. We would like a sort of computer, in effect, which is decentralized in the sense of the internet. Does not have an owner, at least not sort of a single or small number of owners, does not have a single operator. You cannot turn it off with the push of a button. Rather, we would like this functionality to be the product of coordination by a number of different parties. Here's another way to think about it. The internet we can think of as shared global infrastructure for communication. Okay, so for the dissemination of data. And I hope it's sort of clear what these words mean in the context of the internet, right? It's global in the sense that people all over the world are using the internet. It's shared in the sense that we're all using the same internet, right? When you go send email to somebody, you don't worry about like which internet they're using. And it's infrastructure in the sense that, people had to actually build out this network that enabled this functionality for global communication. So if the internet is shared global infrastructure for communication, the vision of blockchain protocols and Web3 is similar, but for computation. So in other words, for data processing, not merely data dissemination. Okay, so it's going to be infrastructure. We're going to have to build a system that enables this functionality. We'd like it to be global. We'd like it to be open to people all over the world, just like the internet is. And we'd like it to be shared. We'd like all these people to, in effect, have accounts on the same computer. So in other videos of mine, you may have heard me talk about the computer in the sky. And this is basically what I mean by the computer in the sky. Shared global infrastructure for general purpose computation. So mental models, right? So on the one hand, if you want, think of blockchain protocols as kind of like your laptop, except shared, like everybody has an account on it. And then also you swap out the hardware of your laptop instead for the internet. That's one way to think about it. Or alternatively, you can imagine starting from the internet and then building a virtual computer on top of it. Those are both getting at the functionality that blockchain protocols are attempting to provide. So what might this technology be good for? Well, on the one hand, I hope this already just kind of sounds like potentially extremely powerful, even if we concretely are not sure what we want to do with it, right? Like obviously the internet has been very, very, very important. It's been really just changed society, the fact that we have this global infrastructure for data dissemination, right? Data processing, well, we know tons of what happens in our lives is basically data processing. So if we could also do that in some kind of global shared way, I hope just intuitively that feels maybe super powerful. Now, To make it more concrete, and also just to sort of illustrate the shortcomings of technologies that preceded blockchain protocols, let me actually get a little narrower. Let me focus on one specific use case for global computing infrastructure, which would be to enable meaningful ownership of digital assets. All right, so there's a lot to unpack in that sentence. And I really want to lean heavily on what are probably strong intuitions you have about what ownership means for physical possessions, right? Like maybe you go and buy something, right? So maybe you're watching this video on a laptop, and maybe you bought that laptop with your hard-earned money, and you rightfully then view that laptop as yours. Similarly, maybe you didn't buy something, but you made it. You made something that didn't exist before. I don't know. You went to the beach, you got some driftwood, and like you built some furniture, right? And again, you view that furniture as yours, as you should, right? And so what does that mean? Well, for example, no one can tell you how you're going to use these things that you own, right? Like your laptop, the store where you bought it could burn down. Doesn't matter. You still have your laptop. You can take it to the library. You can take it to the coffee shop. You don't have to ask anyone's permission to use the laptop in different places. No, it's yours, right? Same thing with the furniture that you built. That is yours. If someone tries to take that from you, that is going to be against the law. But then you think about it, and as all of our lives have migrated more and more to the digital realm over the past several decades, think about it, we're kind of like buying stuff and making stuff in the digital realm all the time. Right? Like as far as buying stuff, right? I don't know, like if you're into video games, for example, it's very common to spend, again, your same hard-earned money as before, that hard-earned money in exchange for an in-game asset, right? So like maybe you sort of buy something cool that your character in the game gets to wear from then on. And we're certainly making stuff in the digital realm, right? So like any content you create on a social media platform, right? That is content that did not exist until you created it. And yet, despite the fact that it is exactly the same hard-earned money that we are spending on the digital assets, right, like in-game assets in a video game, as we are spending on that laptop, okay? I've never met anyone who feels like they own their digital assets in as strong a sense as they do their physical possessions, like that laptop. And even though it's exactly the same time that we're investing, right, to create content on a social media platform versus building driftwood furniture, I've never met anyone who feels that they own their social media content in the same sense that they own their physical possessions. Everyone I've talked to feels this gap in the strength of the property rights that we have for our physical possessions versus what we buy or create in the digital realm. And so one specific use of the computer in the sky, okay, of this global shared virtual computer, one specific thing we can do with it is to enable more meaningful notions of ownership of digital assets by using that computer in the sky to track ownership, to keep track of who owns what. So for this application, it's completely critical that we have the general purpose functionality of a computer, right? We basically need to maintain a spreadsheet which keeps track of who owns what. So we need a real, we have the functionality of a computer to be able to do that. But it's also totally critical that the technology is decentralized. We absolutely do not want there to be a single all-powerful party who has unilateral say over who owns what. We really want sort of this notion of ownership to be the product of coordination by lots of different diverse parties, the same way the internet is. To explain blockchain protocols in Web3, I've been already making these constant analogies to two things you're already quite familiar with. First of all, computers, like your laptop, and second of all, the internet. And I want to now even sort of double down on those analogies. To do that, I need to talk a little bit more about the mental model I want you to have of a computer, of your laptop, and the mental model I want you to have of the internet. And in particular, I want to emphasize parallels between the role of a blockchain protocol and especially the role of the operating system of your laptop, but then also to some extent the role of the internet protocol, IP, in the context of the internet stack. So let's start with the mental model I'd like you to have of a computer, like your laptop. It's going to be a bit oversimplified. I'm sure some of my computer science friends watching this video may cringe here and there over details I'm glossing over, but this I think is the right mental model for you to have for the rest of this video. As per tradition, in computer science and many other engineering fields, I'm going to draw things as a stack of layers. And at the top, that's will be what interacts with end users like you and me. And as we go down the stack, we will be getting lower and lower level, all the way down to things like transistors and wires. So, a computer, like your laptop. You know, when we think about computers, we really probably think mostly about the applications that we use, right? We think about writing something in Microsoft Word. We think about cropping an image in something like Photoshop. And so that is what I mean by the top layer or the application layer. Really just computer programs running on your computer, like Microsoft Word or Photoshop. So when you think about computers, you probably think about the applications on those computers. But at the same time, you know, if you're using your laptop and you actually have your laptop on your lap, say, you know, you're doing stuff, you're cropping images, whatever you're doing, the laptop starts getting warm, right? Maybe you even hear like a fan go on to sort of keep it cooler. So like at some level, we kind of know that while we're just sort of interacting with these programs and giving them high level instructions, we know that eventually those are getting boiled down to like physical operations on zeros and ones. We are aware that there is a physical machine, there is hardware on which sort of our instructions are ultimately being carried out. So that's going to be the bottom layer of this 3-layer stack. So the hardware would include ingredients like the chip or the processor. So that might be made by like NVIDIA or Intel, right? There's going to be like memory, so RAM. There's going to be persistent storage, right? External hard drives. All of that is part of the physical machine. All of that is part of the hardware. So you think about this, you're like, okay, I guess somehow this gap is being bridged, right? I just tell the computer to crop an image and then a bunch of zeros and ones get moved around on this sort of, physical machine. And you could imagine maybe that happened directly. You could imagine that maybe, the sort of software engineers that write the code for Photoshop actually worry about the details of the hardware, like the processor and exactly how much memory they have. You could imagine a world like that. For a lot of really good reasons, that's not actually how things work. At least not how they've worked since like the 1940s. For a long time, it was realized we need a middle layer in between the application layer, in between the computer programs that users use and the physical machine. So in the context of your laptop, that middle layer is the laptop's operating system. So even if you've never really understood what an operating system does exactly, you're certainly familiar with its existence, right? So like Mac OS is the name of the operating system owned by Apple that runs on a Mac computer. Windows would be the name of the operating system owned by Microsoft that runs on other types of computers. Maybe you've heard of Android, which is owned by Google. Those are all examples of operating systems, right? And when your phone issues you a message that like it wants to upgrade the operating system overnight, right? That's kind of the operating system on your mobile phone. So the operating system is itself software. You should think of it as a program, but it's basically the master program that coordinates and runs all the other user-facing programs on your computer. And if you think about it, like you're kind of used to this idea, right? Because like you open your laptop, right, and you have to enter a password maybe just to like see the desktop, say, right? And you should think of that as kind of like unlocking the operating system of the computer, more or less, right? Once you've entered that password, now you see all of the different applications which are running in your operating system, like Microsoft Word, like Photoshop, right? Some of those applications may themselves be password protected, right? If I open up 1Password or a password manager, that's going to ask me for another password distinct from the password I entered to sort of get into the computer in the first place. So that's to give you some color around this idea of the operating system being a master program, kind of the gateway program through which the end user interacts with all the other computer programs, which are the ones you probably immediately think of. And in a little bit, we'll see there's a very strong parallel between this role of an operating system, sort of a master program coordinating all these other programs, with that of a blockchain protocol, like say Ethereum, which you can think of as a computer program which coordinates the operation of a bunch of programs that run inside of it, so-called smart contracts, as we'll discuss in a little bit. So the parallels between your laptop's operating system and a blockchain protocol run actually quite a bit deeper. So let me explain. And let me actually warn you that this next point possibly the most difficult to grasp point in this entire video. It is an important point, however, for understanding the analogy for blockchain protocols, so we'll spend some time here. Okay, we'll give it some time to sort of sink in. All right, so this concept concerns a virtual machine. Okay, so what does that mean? So we talked about how, in principle, you could imagine the developers of Photoshop, the software engineers writing the code of the Photoshop application. You could imagine a world where they actually have to worry about the details of the underlying hardware, right? Like, for example, how much physical memory the underlying machine has. But we also said that's not how things work for a lot of good reasons. So how does it work? Well, the operating system of a computer acts as an intermediate layer that insulates application developers, again, meaning like, software engineers writing the code for Photoshop, insulates application developers from the details of the hardware and vice versa. So how does an operating system accomplish that? It does so by providing application developers with an abstraction known as a virtual machine. Okay, so in some sense, an imaginary computer with an imaginary processor, imaginary memory, and so on. And the gentleman's agreement, sort of the separation of responsibilities, is that the operating system, in effect, tells the application developers, don't worry about the details of the underlying hardware. I'm going to give you this stable abstraction of a computer, virtual machine. Program as if your code was going to run on this virtual machine. Code as if the virtual machine was the real physical machine, even though it's not. Okay? Meanwhile, the operating system takes on the burden of realizing, whatever it is application developers want to do on the virtual machine, realizing the virtual machine instructions on the underlying physical machine. So we talked about how, on the one hand, you're saying crop an image. On the other hand, your laptop's getting warm on your lap. Okay, obviously stuff's getting translated down and moving zeros and ones. What I'm saying here is that fundamentally happens in two stages. Stage one, you saying crop an image, gets translated down into relatively low-level instructions for the virtual machine provided by the operating system. So again, if you're a software engineer, sort of writing the code for Photoshop, you're responsible for translating the sort of user intent of cropping an image down to low-level instructions that the operating system's virtual machine can understand. So that is stage one. Okay, your laptop's not getting warm yet, okay? But at this point, the crop an image command has been translated to lower-level instructions to be run in the virtual machine. That's stage one. Stage two, the operating system says, aha, this is what the application would be doing if the virtual machine were the real machine, the physical machine. It's not, but let me now realize the intended virtual machine instructions with actual instructions run on the physical machine. And at that point, your computer on your lap is going to start getting warm. Now, look, I get it. This is a hard to grok concept, this idea of a virtual machine. Like, it just seems like weird and like, why would you do this? Let me point out, you are all actually quite familiar with this idea of simulating virtual things in software. Okay, this is an idea you're familiar with. Lots of examples, but like, let's take a flight simulator, right? So like you're flying a plane. Well, actually, you're not flying a plane. You're using a computer, but the computer is sort of rendering what would be happening were you flying a plane, right? It's simulating a virtual plane in a virtual world. Part of that flight simulator is a physics engine, right? So it takes the current state of the virtual world, you do some action, like you say turn left a little bit, and then the physics engine is responsible for computing the new state of the virtual world, given the old state, given your old position, velocity, etc., and given the action you just took. Okay? The idea of a virtual machine is exactly the same. All right, so rather than having a virtual world, there's a virtual computer, but just like the virtual world has a current state, where the plane is, its velocity, etc., the virtual computer is going to have its current state, like the contents of its virtual memory. And just like in the flight simulator, you want to sort of simulate what would happen if the virtual world was real and you actually took some action. Same thing with a virtual machine, except instead of turning left, you're executing a line of code. So in the virtual machine, it has some current state, like the current contents of memory. And you just say, suppose we executed a particular operation, like we added two numbers together, or we moved some zeros and ones from here to over here. Simulate what would be the new states of that virtual machine were it a physical machine and you actually executed that operation. Okay, so really the simulation of a physical machine, think of it like a flight simulator, except instead of simulating physics, you are simulating the execution of operations on a physical computer. So hopefully that discussion makes the concept of a virtual machine a little less sort of weird and crazy and abstract, right? It's sort of not unlike a flight simulator, except rather than simulating the effects of actions in the physical world, you're simulating the effect of executing instructions on a computer. But still you're like, isn't that kind of like a weird thing to do? Like, you have a computer. Why simulate a fake computer when you have a real computer? But there's tremendous power in having this intermediate layer, like in this context, an operating system that decouples innovation of the upper and lower parts of the stack. And we're going to see this power of the intermediate layer over and over again. We'll see it again in the context of the internet. We'll see it again in the context of Web3. For example, right, the developers of Photoshop, again, they don't have to worry about the actual physical hardware. They only have to worry about translating sort of user commands down into instructions that the virtual machine can understand. Which means that if the underlying hardware changes, I don't know, you install sort of additional RAM, for example, Photoshop could care less, right? You don't have to sort of rewrite Photoshop. You don't even have to reinstall Photoshop, right? It just works, even though the hardware has improved underneath it. Right, so that's sort of the power. The hardware can improve, the applications don't have to adapt. They can just do what they were always doing as long as the virtual machine provided to them by the operating system stays stable. Right? Similarly, if you're doing better and better hardware, right, faster memory, faster disk drives, whatever, you could care less about what the applications are doing. Your only responsibility is to make sure that it's possible to realize in the physical world the virtual instructions that the operating system is asking you to realize. So again, applications can innovate independent of hardware and vice versa. An incredibly powerful decoupling. So that's the mental model I would like you to have of a computer, right? You already knew there were these user-facing applications, right? Microsoft Word, Photoshop, whatever. You already knew that, the computer gets warm on your lap, so presumably there's some sort of stuff happening in the physical world. There's a physical machine. And now you also know there's this intermediate layer of an operating system. And again, you're familiar with examples, Mac OS, Windows, Android, etc. There's this operating system which in some sense decouples the two. It itself is a program, but it's the master program that coordinates the execution of all the other programs that you're interacting with. So, right, computers, as we know, are quite powerful. So why would we ever need any other technology, blockchain protocols or otherwise? What could we possibly do with some new technology that we couldn't just do with these sort of powerful computers that are available to us? And so to answer that question, I want to again return to this litmus test of meaningful ownership of digital assets, which I've asserted is going to be, in my opinion, one of the main uses of blockchain technology. So why couldn't you already do that just with, say, somebody's laptop? Well, the good news is that a computer, right, as we know, is capable, it's very flexible, it's very versatile, it's capable of a wide range of computations. So certainly tracking who owns what in some spreadsheet, right, as we all know, that is sort of trivial for a general purpose computer to do. Okay, so that's the part of the computer that we're quite happy with, sort of the versatility and power of general purpose computation. On the other hand, there's no way you would use some single physical computer as some kind of global record of who owns what digital assets, right? That would be crazy, right? A physical computer, right, it has a single owner or operator, right? There's going to be someone who can just literally push the power button and turn it off whenever they want. Or anyone with admin privileges on that computer could change the contents of files on it, right? Like, say, a spreadsheet, right? So if all the sort of records of digital ownership were sort of on some one physical computer, right, how would you even learn the contents of the spreadsheet if you don't have an account? I mean, I guess you could ask the owner, but they could lie to you. The owner could change the contents, sort of take your stuff, they could crash and just sort of go away, and then all the records are lost. There's a million reasons why sort of this would be crazy. So we have the general purpose computation, but we do not have the decentralization, which would seem to be necessary to have a meaningful notion of digital ownership. So next, I want to talk about the mental model I'd like you to have for our second very familiar example, namely the internet. Once again, we're going to have a stack of, it'll again be 3 layers, and again, the top layer is going to be user-facing applications. And like with your laptop, you probably relate to the internet primarily via the applications that you use. You think about the internet, you think about sending email, you think about browsing the web, you think about stuff at the application layer. At the same time, in the same way a computer on our lap gets warm, right? If you're browsing the web on your phone, right, it can take a while sometimes for those web pages to load. And so, again, at some gut level, like, you know that web page doesn't live on your phone. You know it lives somewhere else and is getting, communicated to your phone. You know that zeros and ones are getting moved from point A to point B so that you can read a particular web page. We also sort of intuitively know that zeros and ones can be moved from point A to point B via quite different methods, right? Like, for example, with your phone, right? Maybe it's on the cellular network, or maybe it's using Wi-Fi, or maybe you're at home on your desktop using Ethernet. So lots of ways of moving zeros and ones around. And again, you can imagine a world where the developers developing an application like a web browser have to worry about how their zeros and ones are going to be transmitted, whether it's by cellular or Wi-Fi or Ethernet or some technology that hasn't been invented yet. You can imagine a world like that. But especially after our previous discussion, you should be thinking, doesn't it seem like there should be some sort of stable abstraction that developers can, program for? And then sort of separately, that layer insulates from the actual physical reality of how the zeros and ones get moved. And yes, indeed, that is the organization of the internet. The analog of the operating system, the middle layer here, is rather unimaginatively named Internet Protocol, or IP. So the abstraction provided by IP is actually quite simple to understand, much simpler than the discussion of virtual machines, of operating systems, of computers. So IP just provides the abstraction of a digital version of the postal service. Meaning, just like you would take an envelope and put an address on it and drop it in the mailbox to have it delivered by the postal service, the Internet Protocol, you give it a data packet with an address, a destination IP address. If you've ever seen a number like 128.72.0.123, something like that, that's an example of an IP address. So that's what you write on the envelope. That's what you attach to the data packet. And just like it's the Postal Service's job to somehow, some way, hopefully without too much delay, get the letter to the destination, so too is it IP's responsibility to take the data packet and eventually somehow, some way, hopefully without too much delay, deliver it to the physical machine with the destination IP address. And just like our previous intermediate layer, an operating system decoupled the concerns of application developers for a computer from people who build hardware for a computer, so too does this IP layer decouple the concerns of application developers for the internet, like people who write web browsers or email clients, from the concerns of those actually realizing the functionality of the internet. For example, building new technologies to move zeros and ones from point A to point B. And in fact, the internet provides an even more powerful illustration of the power of this decoupling than does something like your laptop, right? Because like your laptop, the operating system is going to get upgraded every once in a while, right? I don't know, maybe a couple times a year, something like that. Whereas, believe it or not, in the internet, IP, right, most of the internet runs on the exact same version of IP that was rolled out in the 1980s. 40 years ago. Okay, so some of the internet has migrated from IPv4 to IPv6. That's happening super, super slowly. Why? Because the internet is so decentralized, because it's the product of sort of implicit coordination by lots of different independent parties. Think about that. This middle layer in the internet, it is the same as it was in the 1980s. Rather a lot of innovation has happened at that top application layer since the mid-1980s. For example, we did not have the web at all in the 1980s. The web was sort of invented as a concept, or the protocols were invented around 1990. The first web browsers around 1993. Rather, a lot of innovation has happened at this bottom layer in the last 40 years. For example, when IP was rolled out, there really was no mobile. Okay? Using the internet really meant you had to be passing zeros and ones over physical lines. Obviously, that is not the dominant paradigm for use of the internet today. So somehow, despite the fact that this middle layer has been ossified, tremendous innovation has happened on the top and at the bottom. Why? Because as an application developer, you do not care about the underlying hardware and physical connections. All you need to worry about is getting your application to work using the functionality provided to you by IP, using this end-to-end routing that IP provides. Similarly, if you have an idea of a better way to get zeros and ones from point A to point B, you don't have to care about how that functionality might be used by applications. All you have to do is satisfy the requirements asked of you by the Internet Protocol, which is basically to get zeros and ones somehow, some way, over one hop from some point A to some nearby point B. So that's our second example of just how critically important these middle layers can be. And on the next slide, when we talk about a mental model for Web3, the middle layer is going to be, wait for it, a blockchain protocol. So now that we have our mental model for the internet, I want to ask the same question I did when we had our mental model for the computer, which is, wow, what an amazing technology. Why would we ever need any other technology beyond this one? So for example, why aren't we already in a position to have meaningful ownership of digital assets? And so with the internet, the pros and cons are kind of reversed with respect to your laptop. Right, so the good news is, unlike your laptop, the internet is definitely shared, right? Everybody's using the same internet, and it's decentralized in the sense that, again, you don't call up the CEO of the internet, right? There's no one owner or operator. It's really sort of the product of kind of implicit coordination by a large number of independent parties, none of whom can easily turn the internet off or otherwise seriously interfere with its functioning. So those are great building block properties for meaningful digital ownership. Unlike your laptop, however, the internet is not meant to do general purpose computation, or really kind of, frankly, computation at all. The internet is only meant to get zeros and ones from point A to point B, the same way that the Postal Service's only responsibility is to get envelopes, packages, etc. from point A to point B. The Postal Service is not doing sort of meaningful processing on whatever in your packages, nor is the internet doing meaningful processing on whatever is sort of stored inside of your data packets. So a technical term here would be internet protocols are generally stateless. Okay? They do not have memory based on what has sort of the zeros and ones that has passed through them in the past. That, of course, means that this is not sufficient to have meaningful ownership of digital assets. Like, conceptually, you need to be maintaining some spreadsheet. The internet is not maintaining anything, spreadsheet or otherwise. So with our mental models of computers and of the internet now solidly in place, I can tell you about the mental model I would like you to have for blockchain protocols and Web3. We're again going to have a stack of layers. There will again be a very important intermediate layer that insulates the top layer from the bottom layer and vice versa. That's going to be the blockchain protocol. And as usual, that top layer is going to be the application layer. Now, all of you, I'm sure, are familiar with the application layer of computers, right? You've used computer programs before. All of you are familiar with the application layer of the internet. You've all, for example, surfed the web before. You may or may not, depending, be familiar with the application layer of Web3. You may or may not have interacted with computer programs that are controlled by blockchain protocols, which, by the way, are often called smart contracts. But they're really just computer programs. They're computer programs that happen to be controlled by a blockchain protocol. Really not a big fan of the phrase smart contract. They're not really contracts. They're not really smart. They're literally just computer programs that are whose operation are sort of controlled by a blockchain protocol. So I'm just going to call them programs or applications. So what would be some examples of the application layer that you may be familiar with? Well, some of the bigger ones include, for example, Uniswap. So Uniswap is a decentralized exchange. So that's a computer program running on a blockchain protocol that allows you to exchange one type of digital asset for another. Another example would be, say, OpenSea. OpenSea is a marketplace for NFTs, NFTs being non-fungible tokens. Famous examples being like Bored Apes or CryptoPunks. So OpenSea is a marketplace where you can purchase NFTs from those collections. Or, on the social media side, one example would be Farcaster, which you can think of as a somewhat decentralized version of Twitter/X. So if you've interacted at all with the application layer of Web3, those are a few applications you might have heard about or maybe even used directly. So what about the other layers? Well, way back at the beginning of this video, I said, you can kind of think about like blockchain protocols in Web3 as a computer, but shared and with the hardware swapped out for the internet. Or alternatively, you start with the internet and build a virtual machine on top. So the bottom layer here, I'm just going to put the internet. All right, we're going to think about building general purpose computing functionality on top of the internet. So now, as mentioned, this intermediate layer is going to be a blockchain protocol, including ones that you almost surely have heard about. The Bitcoin protocol, that's a blockchain protocol in this sense. The Ethereum protocol, that's a blockchain protocol in this sense. Same thing with, say, Solana and a number of others that you might have heard about. There are strong parallels between the fundamental purpose of a blockchain protocol and of the operating system on your laptop. As we've discussed, an operating system provides a virtual machine abstraction to application developers. So, if you're contributing to the code for Photoshop, you don't worry about the underlying actual physical machine. You program as if the program was going to run on the virtual machine, provided to you by the operating system. It is then the operating system's responsibility to do that second stage of translation from low-level instructions in its virtual machine to the actual underlying physical machine. In exactly the same way, a blockchain protocol provides a virtual machine abstraction for use by Web3 application developers. Okay, so if you're developing a Web3 application, right, I don't know, maybe you're sort of, writing code for Uniswap, something like that, the blockchain protocol, in effect, makes you the promise, look, just pretend like the virtual machine I provide you with was the real machine, and then code accordingly. Now, one difference is that the operating system on your laptop, it's providing you with a virtual machine that is backed by a physical machine. Whereas with the blockchain protocol, right, we've swapped out the hardware for the internet. There is no single physical machine behind the virtual machine being exported by this blockchain protocol. But again, that's the point. That's why it's decentralized. There is no single physical machine, but nonetheless, from the application perspective, it is as if you are programming for a single physical machine. And then the final parallel between operating systems and blockchain protocols is, while the operating system of your laptop is in effect a master program that coordinates the execution of all the user-facing programs you might interact with, like Microsoft Word and Photoshop, so too can you think of a blockchain protocol as a sort of master program coordinating the execution of all of the user-facing Web3 applications that run inside that blockchain protocol's virtual machine, coordinating the execution of, for example, Uniswap and OpenSea and Farcaster. So another way of thinking about it is from the middle layer on up. The Web3 stack looks like a computer, but underneath the middle layer, right, we've swapped out the hardware for the internet. Okay, so it's a computer whose computation is the product of collaboration between many physical machines, possibly scattered all over the world, possibly with lots of different owners and operators. Okay, so again, a shared computer with the hardware swapped out for the internet, or if you like, a virtual machine built on top of the internet. So look, I totally get it if your brain's just kind of starting to hurt a little bit at this point. We have made it through all of the hardest material in this video, and maybe some pictures would help just sort of reinforce these concepts a little bit further. So the bottom layer of that Web3 stack that we were just looking at, right, that was the internet. So the internet, as you know, involves zillions of physical machines and physical connections all over the world. So here on the slide, I've shown 25 physical machines. A typical major blockchain protocol would usually be run by hundreds or thousands of physical machines. So for an analogy, we can think about the web, right? So there are physical machines called web servers all over the place, lots of them all over the world. Web servers run software locally supporting Web 1 protocols like HTTP. And the fact that all of these web servers are sort of all supporting this common protocol, the product of all of their efforts is what we think of as the web. So for a blockchain protocol, again, you're going to have lots, ideally hundreds or thousands of physical machines, all running software locally that supports a particular blockchain protocol, like maybe Ethereum, for example. And now the product of all of these physical machines supporting this common protocol is going to be the coordinated simulation of a single virtual machine. Okay? So a blockchain protocol enables a large number of physical machines scattered all over the globe to act logically as if they were a single virtual machine. Now, without context, that seems like a ridiculous thing to do, right? Why would you start with 1,000 computers and turn them just into one, right? But we've talked about that. It's because none of the 1,000 computers are decentralized. Each of those 1,000 computers has an owner that can hit off, and that computer just goes offline. Whereas with a well-designed blockchain protocol, the single virtual machine that's the product of all of their efforts, that is one that nobody's in a position to turn off. It's the machine on the right that has the potential, for example, for meaningful ownership of digital assets. None of the individual 1,000 machines on the left offers that potential. So that covers everything I wanted to tell you about the longer and harder goal of this video, namely to give you some high-level but fundamentally accurate mental models of how blockchain protocols in Web3 work and what is their purpose. Let me now conclude with the second goal, which is to make clear the distinction between what's known as the infrastructure layer or infra layer and the application layer or app layer. So these are quite simple concepts, and you'll hear this terminology all the time by people who work in the area, whether it's in research or engineering or investment. But in my experience, beyond those inner circles, this language isn't so widely known. So I just wanted to take a minute to tell you about it. So the application layer or the app layer, that's where the user-facing computer programs live. So like on your laptop, the application layer would just be the programs you interact with all the time. Microsoft Word, Photoshop, whatever. On the internet, the application layer would include like sending email, browsing the web, and so on. For Web3, as we've mentioned, some of the more well-known applications include Uniswap, that's the decentralized exchange, or OpenSea, that would be the NFT marketplace, or Farcaster, that would be an example of a decentralized social network. So in all three of the cartoons that we looked at, of a computer, of the internet, and of Web3, the application layer was that top layer. If you want to get into a little bit more detail, you can argue about, maybe there's really multiple sub-layers of the application layer, right? Like at Web3, on the one hand, there's the sort of actual smart contracts, the actual code, which is operated by the blockchain protocol. And maybe there's also like a front end, right? Which is just part of the normal web, which facilitates interaction with the smart contract that lives on a blockchain. But whatever, let's put those nuances aside. Okay, so think of that application layer as the top layer of those cartoons that we had. That's the one that as an end user, you're going to be familiar with. So the customers, if you like, of the application layer are just end users like yourself. Who creates that application layer? Well, it's application developers. Okay, so typically software engineers, people who are writing code. The infrastructure layer or infra layer, that's just going to refer to all the layers below the app layer. Those are the layers that provide the functionality that make those applications possible. So in the context of your laptop, you wouldn't normally use this terminology infrastructure layer for like a personal computer, but if we had to, we'd be talking about the hardware, and at least in the story that I'm telling here, it would refer to the operating system as well. In the context of the internet, that would refer to both sort of the internet protocol, that middle layer, and everything below, the physical machines and physical connections which IP operates on top of. So when you're discussing Web3, if you wanted to talk about the Web3 specific infrastructure, you'd be talking about specifically that middle layer, the blockchain protocol. If you wanted to talk about sort of all of the infrastructure necessary to make Web3 functionality possible, that would be both the blockchain protocol plus the original web infrastructure, the internet that lies underneath. Now, for a technology to become super successful, it's important that almost everybody that uses it has almost no idea how it works. It should basically just be like magic, right? And I'll bet most of you have that kind of relationship with your mobile phone, for example. Probably you use it all the time for all kinds of different things. And probably you're blissfully ignorant of almost all ways in which it works. It just works like magic, right? That's kind of the ideal sort of mainstream technology. So end users, right, they're going to know about the application layer. Ideally, they know nothing or almost nothing about the infrastructure layer. Who does need to know about the infrastructure layer? Well, if you are a developer, if you develop applications, well, then, of course, you need to know, for example, what virtual machine you're writing for, right? So if it's in the context of just sort of traditional programming for a personal computer, you have to know about the operating system. If you're talking about Web3 programming, you need to know about the blockchain protocol that you're writing for and its virtual machine. So the users or customers, if you will, of the infrastructure layer are application developers. And then, of course, there's the people who actually make infrastructure possible, that actually create that infrastructure. And those, honestly, are just super hardcore nerds. Those are going to be people, the closer it is to kind of hardware, it's going to be people with a PhD in maybe sort of electrical engineering or material science and engineering. The closer it is kind of to the software side, it's going to be people like me, hardcore nerds like me, PhDs in computer science. Now, if you fancy yourself a bit of a hardcore nerd, well then, by all means, I encourage you to dig in a little bit to how the infrastructure layer works. For example, to look into the inner workings of some of the major blockchain protocols. And so, for example, I've got dozens of hours of videos on exactly that topic on my YouTube channel. But this video is exactly for all of you out there who are not interested in looking under the hood of how this infrastructure layer works, and that's totally fine. But even for you, I think it's you should at least be aware of this distinction, okay, between the app layer and the infra layer. The same way that, when you log into your computer and then you log into a computer program on your computer, you're aware that that's sort of two layers. There's the operating system and then there's the programs controlled by the operating system. I do think that awareness is good to have. For example, you may have heard about this concept of tokens, okay, in blockchain protocols and their applications. And tokens can live either on the infra layer, i.e. they can be controlled by the OS, by a blockchain protocol itself, or tokens can live at the app layer. For example, major cryptocurrencies you might have heard of, Bitcoin, Ethereum, etc., those are fungible tokens controlled by the infra layer, controlled by Bitcoin the protocol or Ethereum the protocol. If you've heard of non-fungible tokens like CryptoPunks and Bored Apes, those are tokens that live at the application layer. And so that's just a distinction that's worth kind of keeping clear in your mind. There's sort of stuff that belongs to the virtual machine's operating system, that belongs to the blockchain protocol, like the biggest cryptocurrencies you've heard of. And then there's stuff which belongs to the programs running at the application layer, like some of the most famous NFTs you might have heard of. And that brings us to the end of the video. So what are the key takeaways? Well, you can guess they're the things that I've said 15 times over the past 50 minutes. What is a blockchain protocol? It is a shared virtual machine. It's like your laptop, but everybody has an account and the hardware has been swapped out for the internet. Or if you prefer, start from the internet, build a virtual machine on top. And remember, never equate cryptocurrencies, let alone a single cryptocurrency, with blockchain protocols. That would be like equating email with the internet. The former being a very, very important, but very, very special application of the latter, being a general purpose technology. So the ideal blockchain protocol combines the best features of your laptop with the internet. On the one hand, the power and versatility of a general purpose computing device. On the other hand, the decentralization, the lack of a single owner, operator, or single point of failure of the internet. And then we concluded with this distinction between, on the one hand, the application or app layer, which is where the computer programs that end users interface with live, and the infra or infrastructure layer, which is all of the layers that make that functionality possible. Hope you enjoyed the video. I'll see you next time.